Hello, grade 12. Welcome back to the channel, Science Therapy, hosted by the one and only science therapist, Uabutiwa Sos Ugobela Wemets. And without any further ado, let's look at these questions that we have here. Okay, so we have question 6. It says in the diagram below, the graph of f of x is equals to 2 cos x is drawn for the interval x element of negative 90 degrees to 180 degrees. Then 6.1 says, draw the graph of g of x is equals to negative tan 3 over 2x for the interval x element of negative 90 degrees all the way to 180 degrees. Then on the grid provided on the answer book, so we're just going to use this one, clearly show all asymptote all the asymptote intercept with the axis and endpoints of the graph. Right. Okay, so obviously for this one, you're just going to grab your calculator and punch in this equation on table, and then you start at negative 90, you end at 180 degrees, and then you use your step as 30 degrees. As you can see that there's an interval here of 30 degrees. Right. Then after doing that, if you are plotting your points there, starting from negative 90, it will lead you to negative 1. And then if you want to plot negative 60, you can see it's saying error there. So that means those are the points where you will have your asymptote. So you just indicate your asymptote like that. You indicate your asymptote like that. And then when we want to punch at negative 30 degrees, it gives us positive 1. And then punching 0 gives us 0. And then punching 30 degrees positive gives us negative 1. And then again at 60, we have another asymptote. So at 60, we indicate another asymptote like that. And then let's continue at 90. It's leading us at 1. So right now we are only concerned about plotting. And then at 120, it gives us 0. And then at 150, it's negative 1. Then at 180 degree, we have another asymptote, right? So where it is saying error, that's where your asymptote is. From your table, there is where it is saying error, that's where your asymptote is. It's error at negative 60, positive 60, and 180. Now, at this point, all you have to do now is try to join this point so that you form your tan graph. So because we can see that from here, from the equation that this is negative, we know that this graph has been reflected over the x-axis. So that means now it has to start from below. So originally the mother graph starts by going upward there, but then this has been reflected over the x-axis. So this must start from below here. And then now it will go like this. Form that S shape here. So it's just a matter of plotting here. And then now, since it ended below here, then it needs to start up there. So joining this, you just form a nice, smooth curve. And then just like that, you have your tan graph. So this is your graph of G. This is your graph of G. So that's all you needed to indicate. So that's all you needed to indicate. That's all you needed to indicate. So the endpoints clearly show all the endpoints. Okay, and then that's how we have it. Then 6.2 says determine the period of G. So 6.2, the mother graph of tan. So tan x would have a period of 180 degrees. But then since now we have tan 3 over 2x, negative tan 3 over 2x, we know that to determine the period, it is always 180 divided by b, which is the b represents the number in here. just right before the x, so the coefficient of x. So that means we are supposed to say 180 divided by 3/2. So now when we punch that into our calculator, we end up with 120 degrees. So the period for this graph 6.2 is 120 degrees. Note how I solved it. So I said the period for the mother graph of tan is 180, but now that I have 3/2 here, I need to say 180 divided by 3/2. Or you can simply write this as 1.5, which is still the same thing. Then you get 120 degrees. Okay, then 6.3 is saying write down the values of x in the interval x element of negative 90 degrees to 180 degrees for which f is decreasing. For which f is decreasing. So where do we have f? So the graph of f, remember, is this other graph for cos. So let's first highlight it. So note that I said with decreasing or increasing questions, you just have to locate the turning point, right? So where is it decreasing? We can see that this is a turning point here, right? So our turning point there is found on the x-axis. So let's first locate our turning point or our stationary point. Can see that it is there. So now they're asking where is the values of x in the interval for which f is decreasing. So at this point, we can see that the graph of f is increasing because if you were to draw a straight line here, it will have a positive gradient. But then looking at this part here, if you were to draw a straight line like this, then you would see that the straight line here would have a negative gradient, meaning that the graph is decreasing at points between 0 degrees all the way up until where the graph will stop there, right? We can see that the graph ends there at positive 180 degrees, right? So all the way up until that point. Okay, so now in writing the solution to that one, we should say 6.3, the graph of f is decreasing at points where x is an element of 0 degrees all the way to 180 degrees, right? So from x element of 0 degrees to 180 degrees. Again, we don't include the 0 and 180 because we are saying that at that point, the graph is not increasing or decreasing because those are turning points, right? Those are turning points. So at this point, the graph is not increasing or decreasing. Also at this point, it's not increasing, it's not decreasing. It is simply stationary, right? So that means it only decreases in between 0 degrees to 180 degrees. Okay, then 6.4 says use the graph of G to determine for which values of x will G of x be greater or equal to 1 for the interval of negative 90 degrees to 180 degrees. Where do we have our graph of G being either equal to positive 1 or above positive 1? So let's just indicate like this. Nice. So now we can see that from this point all the way to the asymptote, this is where we have our graph of G being either equal to 1 or above 1. Right. So the first point that we have there for 6.4 is we can say for 6.4, we have located that in between here, this is where we have the graph of G being above positive 1. Right. So we're going to say when x is an element of negative 60 degrees all the way to negative 30 degrees. But then the negative 30 degrees is included. Why is it included? Because at that point, that's where we find the graph being exactly equal to positive 1. So remember, they said where it is either greater than or equal to positive 1. But then again, there is another point where we see that occurring here at this point. So in between 60 and 90. So we're going to say x element of 60 degrees all the way to 90 degrees. And then include the 90 because this is the point where it is exactly equal to positive 1. Now, why am I not including the negative 60 and the 60? It's because the negative 60 and 60 are actually asymptotes. So we are saying the graph of G will not exist at that particular point, right? So this will occur at values that are greater than negative 60, but then are either equal to negative 30. And then also for values that are greater than positive 60, but then have to end at 90 degrees, right? Then those are your two solutions for that. Those are your two solutions, right? So you write it in that form. Or if you prefer this, then you would say negative 60 degrees here. And then here you would have negative 30 degrees. And then you would have or 60 degrees here. And then x less than or equal to 90 degrees. So this is one and the same thing. This is one and the same thing. It's just a matter of which notation do you actually prefer. Now, 6.5 is saying, so let me erase here. It's saying the function h is obtained by translating the graph of G 30 degrees to the right. Write down the equation of h. So to write down the equation of h, let's first write the equation of G originally as it is. So the graph of G, we are given negative tan 3 over 2x. But then we are being told that the graph of h of x is being obtained by doing what? It is being obtained by shifting the graph of G 30 degrees to the right. So 30 degrees to the right, if it's saying to the right, remember, we should use a minus sign. So that's minus 30 degrees. So that means the graph of h of x is this. So meaning the graph of h of x will be obtained by simply replacing the x here with the x minus 30 degrees. And this becomes the equation of the graph of h, right? But then if we were to further just try to calculate this one, then we will end up with negative tan. And then if we say 3 over 2 multiplied by that, that's 3 over 2x. Then if we say 3 over 2 multiplied by negative 30, we end up with negative 45 degrees. So we end up having the equation of h of x as this, simplified, right? Okay, and that's it for the lesson, guys. Please press the thumbs up button if you've enjoyed the lesson and then you have found it helpful. And if you've been watching the videos and haven't subscribed yet, please hit that subscribe button. But most importantly, please share the link with your friends and classmates so that they may also find assistance. Remember, do not be selfish. We are winning as a team.